Thank you. Hello, good afternoon, everyone. Hi, and thank you for coming to this parallel session on pre-normative research for standards. As we mentioned this morning, pre-normative research is part of the activities that we support within the cross-cutting issues research area. And for us, it's a key area to support regulation codes and standards. Today, this afternoon, we will have the presentation of 4 projects, and as I mentioned as well this morning, I believe that they represent a very good sample of the type of projects that we are supporting, addressing the whole value chain and addressing different aspects of the hydrogen technologies, but also the fuel cell technologies. Over this presentation, over the day, we will review the different projects. At the end of each presentation, you will have the opportunity to make questions. Don't forget to make questions as well in Slido. My colleague Nikos is managing Slido. Thank you, Nikos, for this. And at the end, after all the presentations, we will have a panel discussion. And today we have the opportunity to have one scientific officer of the Joint Research Center of the European Commission, Beatriz, Acosta, Iborra. Thank you, Beatriz, for coming. And I look forward for the discussions after the end of the presentations. With this, and without further ado, I would like to introduce the first speaker to the stage. And in that sense, I would like to welcome Vincent Mattelaer from Toyota Motor Europe, who will present on behalf of the PRHYDE project. The PRHYDE project is a very interesting project, and the title and the focus is developing the protocol for heavy-duty hydrogen refueling introduction and key results. So, Vincent, the floor is yours. Thank you for coming.
Thank you very much. I have to use this one, I guess. The big button. The big button. Okay, so I'm going to present the PRHYDE project here. And this was actually a very nice project, a very special project, because although it's a European project funded by the European Union, the Clean Hydrogen Partnership, thank you very much, there were a lot of international companies involved, because we are talking about standards, international standards. So there were Japan partly involved, but also the United States was very strongly involved with this project. So to give you a background, we all know about the fueling stations for passenger car vehicles. There are already over 200 of them in Europe, and they are working quite fine. Thanks to the current protocol, which is the SAE J2601, we are able to compete with the diesel and gasoline fueling, because we can have a full tank, 650, 700 kilometers range, and fuel in only 3 minutes to 5 minutes. Hardware is available all over the world, exactly the same type, exactly the same standard, with a nozzle of a maximum 60 grams per second. There was also, within this protocol, a possibility to fuel heavy-duty vehicles, was possible, but there is a quite big gap. The SAE J2601 for we call it the D tables, or the D category, was coming from the Japanese standard, but it was also using the same nozzle as for passenger cars with a maximum of 60 grams per second. So it was quite limited, and if you wanted to fuel quite big quantities, it would take really a long time. It could take 30 minutes, 45 minutes. Time. And so there was a need for not only a new protocol, also new hardware to fuel a bit faster in order to compete with diesel vehicles. So I just explained you the existing standard. So the new standard, we did not develop really a standard at the PRHYDE group. We developed the foundations to build a new protocol. And these foundation stones will be forwarded to the ISO working group 24, which is developing the ISO 19885-3, which will be a fueling protocol for heavy-duty vehicles. Although I must say it's not necessarily vehicles, it could be anything, boats, ships, no, it doesn't matter what it is, as long as it has tank sizes between 10 to 100 kilogram. So if you want to go above that, then of course another type of protocol will need to be developed. It is also assumed that there is a good, safe, reliable communication between the vehicle and the station. So we did not work on the communication system. This will be work for the ISO 19885-2 standard. So that's another working group. We only assumed that this was available. So all this information has already been forwarded. To tell you also, during the development, we did not only look at the refueling time, we wanted to achieve easily 80 kilograms within 10 minutes of gaseous refueling. We also made sure that a maximum SOC could be reached properly. And also, and this is new, we also looked at the TCO, or the power requirements of the station itself to reduce the efficiency, so that we do not need to fuel at extreme low temperatures, for example. So when I talk about the PRHYDE protocol, I first need to explain you the different type of protocols. We can divide them into the 3 different types. Type number 3, the most advanced one, is a protocol where the station will be extremely dynamic, will take use dynamically of all the vehicle sensors. So pressure and temperature, tank temperature sensors, during the refueling itself. So it's very dynamic. There could even be possibilities that the vehicle commands the station how to refuel its own vehicle. While type 2 protocols, those are protocols where first the communication will send all static data, all information about the tanks and the tank properties and so on, and then the station takes over and he will do all the refueling using that data. While type 1, which is for example the SEJ2601, there is actually no communication necessary, and the station itself will take all responsibility for fueling the vehicle. So now that we know these 3 different types, within the PRHYDE working group, we developed actually 4 different protocol concepts. One is a type 2 static data protocol, and there are 3 different type 3 protocol concepts, which we call T-gas initial plus, and T-gas throttle. I will explain that a little bit more in the future. So we did not work on a non-communication protocol yet. This was a decision made from the very beginning, and this will be taken over by the SAE-J2601-5 standard. So this working group is working on actually using the same principle as the PRHYDE protocol, but for a non-communication method. So before I explain you the PRHYDE protocol, I first need to explain you a bit the drawback of the SAE-J2601 protocol. In that case, the station had full responsibility, which means the station actually does not know anything at all of what it is fueling. So everything which you see in purple and in black colored on this slide, it assumed the worst case condition. So the worst type of tank thermal properties, the tank size, the number of tanks, etc., the pipes, the delta P, etc. We took the most conservative way. And that's why on using the SAE-J2601 for heavy duty, the fueling would be way too slow. So what PRHYDE is doing, it is eliminating the whole black part. So the only part where we do make assumptions is for the purple part, for the hose and the nozzle. So obviously we don't want to send all the thermophysical properties from the tanks to the station, because this is very often confidential information from the tank manufacturer. So that is not going to happen. So how did we solve this problem? Well, the OEM, or the tank integrator into a vehicle, he has to put all the thermophysical properties, design, etc., into a model that will appear. It is based on H2 fills, and together with some assumptions of the dispenser components, and then a T-final table will be produced, or multiple T-final tables. And the vehicle, when it arrives at the station and connects to the dispenser, he will send not only what type of protocol he is using, but also the T-final table, and will tell the station, look, please use this T-final table for your fueling methodology. So what does it look like, such a T-final table? It's a simple table of, in minutes, how long the fueling should take. And on the y-axis, you can see the ambient temperature. So, of course, the warmer the ambient temperature, the longer it will take. And on the horizontal axis, there will be the MAT value, the mass average temperature, which is mainly based on the dispenser temperature. So obviously, the colder you fuel, the faster you can fuel. And with the SAE standard, you always needed a minimum of minus 17.5. This is not necessary anymore. The OEM could make tables up to ambient temperature or even higher, if he wishes so. So using this on the top right, you can see that based on ambient temperature and dispenser temperature, you have a certain T-final value. And based on that T-final value, you can perfectly calculate a ramp rate, because it knows the initial pressure, it knows the end pressure, for example, 87.5 megapascal, so you can easily calculate what the ramp rate is. And then if during the process, the temperature varies during the fueling, gets colder or warmer from the heat exchanger, the pressure ramp rate will adjust accordingly. So this is based actually on what we call the MC formula. It's called the advanced MC formula. And the 4 types of protocols that have been developed are a type 2 static, so where we only provide the information before the fueling starts, and then there are 3 others. The T-gas initial is actually a protocol that always also takes care of the initial pressure of the tanks. If it goes to the station and the initial pressure is, for example, 20 megapascal, then you can fuel faster than if the initial pressure would be 3 megapascal, for example. So the vehicle itself will look at its own initial pressure, and then will send the table accordingly. The third type is also a type 3, so dynamic one, which is called T-gas initial plus, and this goes a little bit further. It does not only depend on the initial pressure, but it also depends on the initial temperature, so the temperature of the tanks when the vehicle arrives at the station. Very often this could be much less than ambient temperature, depending on the driving behavior of the vehicle, and so you can fuel a bit faster. Obviously, if you have this third type of T-gas initial plus, you will have many, many more tables inside the vehicle, so it's a little bit more effort for the OEM to create all these tables. And the fourth type is a T-gas throttle, and T-gas throttle is a fully dynamic one. Here, the fueling methodology will depend on the gas temperature of the tank during the fueling. So if it notices that the gas temperature rises faster than it does inside the tank itself, then it will adjust accordingly. So obviously, you will need a very safe and secure measurement of your gas temperature in that case. So it will need to be very precise. So the further you go down, the more important the sensors are for the vehicle itself to have a very safe and reliable signal. While in the case of static, it's okay if there is a small tolerance. So in case if it's not sending any table, then it will use probably the -5 from SAE J2601, which is a very conservative method. And here are the results, and this is the nicest slide of all of them, where you can see in the blue graph, which is the current D category of the SAE J2601, where we are going to do some fueling. And you can see that as soon as we go into the MC formula high flow general, which is the -5 version, the green one, it's double the speed. And as soon as we go into the 4 PRHYDE protocols, which are the 4 last colors, gray, red, yellow, blue, the speed goes super fast compared to the current protocol. And we can compete with diesel fueling. This has been simulated at NREL and at ZBT in Germany in real-life conditions, and of course simulations via modeling. And so here you can see the people who worked on it. Not only the active members shown on the top right are important, but we would also like to thank all the companies below who have made a large contribution, including NREL and First Element Fuel from the United States. So I'm sorry, I'm over my time. Thank you very much.
Thank you.
I apologize.
It's okay, Vincent. A very quick question from my side before you leave. No, because I think it's very interesting that you have definitely progressed state of the art and bringing this protocol. My question would be, what's next now? When are we going to have this protocol in place so that everyone can profit?
Self-consumption benefits of fuel cell micro CHP. We had the Technical University of Lucerne, Switzerland, looking at the economic value of micro CHP participating in power and grid service markets. We had 3 archetypes: Germany, Belgium, and the Czech.
6 research partners and 1 industrial PEM fuel cell stack manufacturer. HYDRAITE project was about the hydrogen quality for transportation applications. The project had kind of 3 issues that it wanted to tackle, or 3 main issues that it wanted to tackle. First was that before HYDRAITE project there was still lack of representative data for the ISO 14687 standard, so standard for hydrogen fuel quality and the impurity limits in it. HYDRAITE studied effects of contaminants originating from the hydrogen supply chain and developed methodology for determining the effect of contaminants in automotive PEM fuel cell systems. Second thing, quite important actually, that before HYDRAITE project there wasn't any European hydrogen quality laboratory available that could do the full analysis according to the hydrogen fuel standard 14687, and of course here in Europe we are talking about its counterpart EN 17124. Within the project, 3 European laboratories were established and ready to offer their services for the fuel cell and hydrogen community. Third, it was also noticed that there was still lack of public data on fuel composition from the hydrogen refueling stations. And within the project, there were 3 sampling campaigns conducted, so sampling hydrogen from the HRS as well as inline monitoring. So first major action, impact of contaminants. Within the project, 6 laboratories, 6 partners established test stations, test systems for PEM fuel cells, for PEM fuel cell stacks especially, with anode gas recirculation and online gas analysis. Fuel cell measurements were completed with CO2 sulfur, or actually sulfur recovery, to be more accurate, also with ionic liquids, freon and toluene. As an outcome, so recommendations were derived from the stack contaminant measurements in automotive type operation. Test protocols were proposed. As mentioned, all the partners completed test systems, similar type of test systems for the short stacks. Also, CO13, so isotopic carbon labeled CO, was used for contamination studies and demonstrated and published, and sulfur poisoning measurements within the short stack environment were completed. 3 European laboratories were set. So before the project there was none, and if you wanted to make or have a full analysis according to the standard ISO or EN, you needed to ship the samples from Europe. So NPL, ZSW and ZBT set their laboratories with analysis according to these standards EN 17124 and ISO 14687, and also with partial compliance to ISO 21087 that became normative during the project. During the project, inter-comparisons were made between these laboratories, starting with pre-mixed gases, then continuing with the samples from the project sampling campaign. The first one, where also a comparison with the external laboratory was made, and then finally in the latter part of the sampling campaigns, or second and third sampling campaigns involving both sampling and analysis. So as a result, all these 3 laboratories, NPL, ZSW and ZBT, reached very good quality on their analysis compared to each other and in relative to the ISO 14687 limits. Sampling campaigns were conducted. We collected a total of 30 samples from the hydrogen refueling stations. First sampling campaign was conducted 2019, collecting 10 samples from Norway, Sweden and Germany, and analyzed by all these 3 project laboratories plus 1 external. The quality was good in all the samples. After this, as we know, COVID-19 made times a bit more difficult, so 2020 the activity was completely on stop. Luckily, then we continued the project 9 months 2021, and with some mitigation measures were able to then complete the sampling with second and third sampling campaigns. The modification was so that these were only conducted in Germany and by the German partners we had. So ZSW conducted the second sampling campaign and ZBT the third one. The quality was good, however in the third sampling campaign some violations were found with water, oxygen and nitrogen. In addition to the samplings, we also did inline monitoring of hydrogen fuel quality, and the concept of pen-based sensor was established on laboratory scale, so both in fuel cell and H2 pumping mode. And also the refueling station online quality was monitored over 30 days period in the end of the project. So, materialized the risks and challenges. Definitely there were some. Mostly they were about delays due to various reasons. What could be mentioned that, first of all, the establishment of the test benches took more time and resources. Perhaps the manual labor might be slightly overlooked, or the manual work needed might be slightly overworked in various applications, as in ours. There was some delay also setting up the laboratories due to other delays, but also, as I mentioned, there was this additional requirement of the ISO 21087 standard. That is a standard of methods for the instrument calibrations that became normative, which was not expected. The inline monitoring of hydrogen fuel quality, to be honest, this was something that was tried to accomplish already in the preceding project, HYCORA. And for some reasons it was not completed at that time and was then moved to this project. So there was a partner who already had the instrumentation for this task. However, what happened was first that 2019 there was this unlucky event incident at the refueling station in Norway, an explosion which of course then halted all the everything in Norway for quite some time. Before that we had quite well established where to put it and when and how, but then we had to rethink everything. Then came COVID-19, which halted all other thinking how to travel and move that system elsewhere. Luckily, in the end of the project, we were then able to take the equipment, analysis equipment, and put it on a station in Ulm, so close to one partner ZSW's premises, and complete the inline monitoring. HYDRAITE was largely pre-normative project. However, the establishment of the hydrogen quality laboratories was something to fully exploit. We took part of results booster, and through this service also another key exploitable result was identified. However, the online hydrogen quality sensors, the stage where they are is a very early stage in comparison to the establishment of these hydrogen quality laboratories that actually started giving their services already during the project. The most impactful results were the 3 European hydrogen laboratories published technical data on hydrogen fuel from the sampling from the hydrogen refueling station, methodology development for determining the effect of contaminants in automotive PEM fuel cell systems, and then of course transferring plenty of this information into the standardization. HYDRAITE had 3 workshops along its way, also some invited presentation in other workshops, as well as conference presentations. Up to date we have 5 peer-reviewed publications from the results of the project, and one big part of the dissemination activities of the project has been the active participation to standardization work. Despite how it reads here, the main work groups would be 27, 28, and 33. So the working groups, ISO working groups for the hydrogen fuel quality, quality control, and then the recently established working group 33, which is for the sampling from the hydrogen refueling station. We also had international networking with Arianna, and last but definitely not least, I would like to remind you that all the details I did not mention here can be found from the deliverables as well as from the publications. So HYDRAITE has most of its deliverables public, and they can be found from the website. Thank you for your attention.
Thank you, Jaana. I would like to open the floor to this audience. Are there any questions? Yes, here we have.
Thank you very much for your presentation.
I think we need a microphone, maybe. Otherwise, at home or remotely, they might not be. Let's go ahead in the meantime.
Thank you very much for your presentation. It's very, very nice to see. I have just a very quick question. So the online monitoring, was it done by EMCell or who did you partner with?
It was SINTEF.
Sorry?
SINTEF.
Okay.
Yes.
Are there any questions? Yes, we're here, the gentleman.
Very quick one. Those 3 labs that have been established, are they ISO 17025 certified?
The laboratories.
Yes.
Well, as I've understood, as I've come to learn, usually the laboratories are accredited. However, when we are looking the hydrogen fuel quality assurance, there isn't actually that kind of accreditation that could be made currently. Of course, each of the laboratories do accreditations according to some other ISO standards. That's quite standard procedure for them. However, it does not fully apply, especially to this case. And that was the main reason why we had these inter-comparisons. So kind of have some kind of public evidence, but that is work ongoing.
Any last question for the audience? No, I would like just to take
Another
one
one.
minute. Yes, go ahead.
Sorry to take the floor. You make the differentiation between sending collected gases to the different labs and doing online monitoring. I suppose that you have a well-established standardized procedure or process for collecting samples, sending them to the respective labs, having them pre-treated in the same way before analysis.
Well, we wish we had, but I think this is part of the standardization work. So what happens is that the sampling, there used to be an annex 1988-0, part 1, annex K, if I don't remember it incorrectly, which was about sampling. Now there is a work ongoing, also because of the results from HYCOR and HYDRAITE project, that it will be an own standalone standard. So that is work ongoing. Then what becomes, well, first of all, of course, there's the preparation of the bottles that you use for collecting the gas, and then you have the sampling, and then you have the shipping, which might be the most straightforward from here, and then you have the laboratories who analyze it. So the treatment of the bottles, or which kind of bottles you should be using, that's not standardized. There has been some studies made, partially initiated also within HYDRAITE, now continued example Metro High V2, that is EMPER EU project. So about the gas bottles and the treatment of them. And then you have the sampling, and then you should have the sampling equipment, and you don't have, currently you don't have any commercial sampling equipment on the market. Within HYDRAITE we were able to compare 2 sampling equipment. One was the Linde Linde's former equipment, and then another one in-lab made by ZPT. So that comparison is available also from the results, but that's not standardized. Then you have the laboratories who receive the samples. As I mentioned, now there is a standard for the methods, methods for the analyzed equipment that they have to follow. So that is standardized. And then of course you have the standard itself about the limits. But there is still plenty of work in this field, definitely.
Very good, thank you, Jaana, and congratulations for the work as well. I think it's impressive the work that you have in HYDRAITE. I just wanted to make a question so the audience know. Are the laboratories, let's say, accessible? Anyone that is producing hydrogen or using hydrogen can send samples to these laboratories and they check that the hydrogen comply with the specifications?
Yes, as long as you agree with the costs, of course, naturally.
Very good. Thank you very much, and let's give a round of applause to Jaana. And let's continue with the next presentation, and I would like to call to the stage Arianna Bionda from the Politecnico di Milano, who will present the e-SHyIPS project, which stands for Ecosystemic Approach Toward Hydrogen Passenger Ferries Pre-Normative Research.
Thank you.
Thank you, Arianna. The floor is yours.
Thank you very much. Thank you. So I'm Arianna. I'm presenting you the project e-SHyIPS in behalf of Politecnico di Milano and the coordinator team. So this is a bit of identity card of the project. You see here that we start just last year, the beginning of last year. So we are quite at the 40% of our project, less than half. And the coordinator is Polimi, but indeed we have a large group of partners. They come from research group. We are our research group, Cineca, this is a center for high computing in Italy, Athena and VTT in Finland. Then they are producers of, let's say, building blocks for hydrogen, like Wojciechowski and Proton Motor. Then they are also certification and standardization body, really important for us. DNV in Greece, and UNI, that is the standardization body in Italy. And then we have operators of the naval architecture, so the market. We have Damen in Netherlands, we have Genova Studios for safety engineering in ships, we have Levante Ferries, Danaus, and the port, Kyllini port in Greece. So you see that's what we call really an ecosystemic approach. So starting from the bottom of the research. Why? A bit of context about it. Also with Lionel Boiro words this morning, you understand that the ship ferry market is really particular. We have ships that now is running or testing in prototypes with hydrogen on board. However, there is not a certification framework in place. What does it mean? It means that if you want to certificate your vessel made with the hydrogen system, you have to follow the alternative design process of the IMO, the IGF code. IGF code is the code for low flash point fuel. It's strictly designed for LNG, but we all know that LNG and hydrogen are not the same things. So how naval architect could apply the rules for low flash point? There is no way. We have to follow a process where we have to, in some way, demonstrate to the certification body and class society and flagship and flags that our boat is the same, let's say, safety and reliable as a normal power diesel propulsion fuel. And you can understand now how this is a challenge for ship owner and ship operator. So the e-SHyIPS project aims to build a regulatory framework to boost the sector that we have, and decide to proceed with the gap assessment, so to assess the gap in knowledge and to generate and create the missing knowledge that is provided by experimental data on 4 main pillars, and propose a pre-standardive plan targeting directly IMO and the IGF code update. But on the other hand, as some of the researchers, or a lot of the researchers, as you see, are coming from the industrial sector, we want to also provide a roadmap for the adoption of hydrogen on board of passenger ships, and also to provide tools, method for design such kind of boat. So a set of guidelines for them. We are moving with the ecosystemic approach, we say, so we think that we cannot be alone in this process. Even if we have 14 partners, we cannot be alone. So we involve from the really beginning other company in the advisory board, so the markets, the maritime markets, but also other producers of stocks or Air Liquide, for example, to distribution of the hydrogen. Then we connect with the other projects, some projects that also were presented during these days here, and we have a real-time feedback with the committee, the technical committee that are there, especially in the SENS and ELEC and the ISO. So we succeed in getting, let's say, a link, a liaison with the IMO directly with a member of our advisory board that is inside the technical committee ISO CC7, that is the one that is updating the IGF code for hydrogen. And all that, let's say, technical committee and policymaker are also confirming that our bottom-up approach, so understanding the gaps of the regulatory from the perspective of the naval architect and the ship operator and ship owner, to leverage the knowledge also from experimentation that is made in the research center. A bit of achievement. Remember that we are neither at the half of our project, so we, as planned, we are in the moment to verify and assess the gaps that we have in the normative and transform it to the experimental to leverage knowledge from the laboratory test. So we were able to map roughly 100 gaps of all the chapter of IGF code. To do that, we involve also the advisory board in 6 workshops, both in presence and online, that was run last year. We had also matches, international standards for non-maritime H2 and for LNG or other fuel in maritime to those kind of gap, to understanding if some standards are already in place, and we are now setting up the experimentation to make in the laboratory, in the facilities of our partner. So we continually connected also with the SENS and ELEC, the technical committee 6, that they are developing also assess the gaps in normative. We already have meeting to in some way verify the methodology and the first assumption that we made at the beginning. We had a meeting 2 months ago to verify first result, and then we will have a meeting in January, February to align their gaps with our gaps and to in some way cooperating for the roadmap, because we really understand that if standards needs to be built on knowledge of the sector, but in the knowledge of the sector in the maritime is not so strong, in some way we have all to cooperate to arrive to a common results. We cannot, let's say, leave the regulation limiting naval architects and ship owner in producing and in proposing ships on H2. So we have to be as much as comprehensive as possible. So for what concerns the experimentation, they say we define a plan that is based on 3 different scenarios. It means that even if the project must be vessel independent, because we do not have to design a vessel, but we have to find common knowledge for a market purpose and to have a platform on which making the experimentation. We set up 3 different scenarios based on 3 different profiles, as you can see here. So we firstly decided to work on small water bus ferries that will be equipped with the hydrogen 300 bar compressed and PEM fuel cell. Then we were working on the RoPax ferry. The operational profile is the Levante Ferries, one of the partner making trips along Greek island that will be equipped to, let's say, different scenarios. The medium one we call, that is compressed hydrogen 700 bar plus PEM fuel cell, and the second one will be liquid hydrogen plus PEM fuel cell, and the large scenarios. That is a raising market of the cruise shipping, smaller luxury cruise shipping, because the large cruise shipping, speaking also with the operational company, is a bit ahead in the research. And we are working here with system of liquid hydrogen PEM or SOFC fuel cell. So we are a bit more at the middle of designing this vessel. It means that design the building blocks of the system and design the general arrangement of the vessel as a platform for the experimentation. And we started to make the experimentation of our 4 pillars, that is ship design, safety system, materials and component, and port and bunkering. In ship design, we are evaluating the stability, not only, let's say, the feasibility of the system, H2 system itself, but the stability of the boat, the behave on waves, and the behaves in rollings and pitching, and the acceleration of gravity, what, let's say, is affecting the boat itself. In safety system, everything that, meaning, let's say, safety corridor, operational, and barriers, explosion, dispersion, emergency discharge for the vessel. In materials and component, the system itself, thanks to the involvement of proton motor that will study the stacks, inclinating and vibration and shocking, and VTT that is studying especially the component for the system and the tanks and distribution, and then port and bunkering. On the side of infrastructure, what is needed for the different scenarios, and operations that needs to be done in port, that will be carried out also in linking our project with the project on the port and facilities that are running now. So the challenges here is that we cannot imagine that with 4, 5, 6, even different general arrangement of the project, we could arrive to establish knowledge that is valid for everyone. So we are working with verification loops, starting from the smaller to the medium and to the large, and understanding if what we learn in the smallest case is also good for scaling up the solution and the guidelines for other types of vessel. To do that, we are involving the advisory board as well, and also other design studios and naval architecture studios that are now working on the same issue. The same, let's say, small challenges that we are facing is that standard needs to be done on the knowledge and on the state of the art of the technologies. For large vessel, the components are maybe not so developed yet, so we have some criticalities in getting information for such large system. For what concerns our main results, that they will arrive at the end of 2024, but hopefully also a bit before, and we are working to, let's say, giving feedback in real time to the certification body and to the technical committee of ISO and IMO. We have the strategic standardization plan for the IGF code update, so the pre-normative workshop that will be written with a liaison with the technical committee CCC7 of the IMO, and a roadmap that will be more targeting ship owner and ship operator and ferry market with best practice value proposition models, and tools and models for ship design and early stage risk assessment. So here you can see also the next event that we are proposing is a workshop on risk assessment for design and bunkering, where you are all invited, of course. You will see also the channel of our project, so if you want to connect with us and subscribe our newsletter, we will get in touch for all the activities that we are doing and a bit of the result that is in this 1.5 years we achieved. So the conference and workshop organized with the International Technical Committee and the scientific publication that are open access, of course, for all of you. Thank you very much.
I see no questions online, so I would like to open the floor. Yes, the gentleman at the back, please.
Thank you, Mr. Chairman. Good evening, citizens. My name is Angelos Harlaftis, Epafos Advisors. I'm working in the progressive science, on the edges of science, 15 years here in Brussels. So I saw the Germans, they have a machine for the production of hydrogen for a ship, a big machine. And also I know 3 years ago at the Commission we made a meeting where we had, they presented an experiment, a big ship around, I think, 30,000 tons it was, which was using renewable energies. We have a problem, I think, in your work. What are the problems you are facing? Mainly, I think it's the sustainability, maybe. And if it is this thing, why don't you combine with the air, the wind, and the solar? Because the wind especially is very ancient. Thank you very much.
Thank you. Yes, there are projects ongoing that try to combine wind energy with hydrogen. There are also some national funding. I'm speaking from Italian research. There are national fundings that are trying to combine wind energy on board and hydrogen. However, the target of the call was exactly to try to have at least 90% of energy produced by liquid or compressed hydrogen, neither carriers, and to have the boat running for at least 90% of the power generation from that source. It's quite a challenge, we recognize that. However, we think that it's possible. Let's say when we start was a huge challenge. Now it's a quite big challenge, but we think that it's not impossible with the technology that is running fast, and a lot of companies from the industry are supporting us, also giving the last, let's say, updating for what concern the stacks and the tanks availability. So it's something that we can achieve. But of course, this could be another open point for research. Thank you.
Very good. Are there any other questions? Yes, the gentleman in the second row.
Thank you. Is it possible for you to exploit experiences from hydrogen-powered vessels already operating in harbors, but not powered by fuel cells, powered by engines?
Yeah, we thought at the beginning to use double combustion engines, so internal combustion engine with hydrogen. We explore this possibility. There are vessels running with these technologies and vessels running with fuel cell. However, the clean hydrogen is targeting fuel cell really strict. So in some way, we think that we have to support this research really strongly.
Yeah, but tank safety is the same, buoyancy problems are the same.
Yeah, that's true.
Very good. A very last question from my side, because you mentioned that you have performed a gap assessment so that you can select the gaps and address them through the 4-pillar experimental campaigns, no? Just for the audience to give them an idea of the work that we have in front of us. Do you have a number of the gaps identified within
Yes,
the, yes?
98 at this
98.
moment.
Okay, and how many of those do you think the project will be able to fill?
We were able to already, let's say, match 35 of those gaps with current standards. We are now planning the experimentation phase, so building the blocks. We already design test for roughly 40 of them. The process is ongoing. There are some kind of gaps that we realize that is quite not possible to fill with the knowledge that we have now. And some of them that are, the last part of the IGF code is on operational procedures, important training of seafarers. That part we believe that is closest to the training area of the project. So probably that part of the IGF code we will not contribute so much.
Perfect. Good luck for the
Thank
rest
you.
of the project, and thank you for coming and presenting
Thank you very
with
much.
us. Let's give a warm applause to Arianna, please. Let's finalize the round of presentations with the project at the ASTRA, and I will not call to the stage because it's online. And at the ASTRA, the title stands for Harnessing Degradation Mechanism to Prescribe Accelerated Stress Test for the Realization of Solid Oxide Cells Lifetime Prediction Algorithm. It will be presented by online, I believe, yes, by Massimiliano Della Pietra from ENEA, Italy. Massimiliano, thank you for being with us, and off you go.
Thank you very much, Mr. Chairman. Can you hear me? Can you hear me, Mr. Chairman?
Yes, we can hear you very well. I guess that we will see also the presentation very quickly.
I'm going to share by myself.
All is set. Go ahead.
Thank you very much. As you said, I'm here to briefly give you some information about the results achieved by the ASTRA project. Going through some numbers of the project, we had okay, the project started the 1st January 2019. The expected duration was 3 years due to pandemic crisis and other issues. So we had an extension of 8 months. So the project ended just a few months ago, the 31st of August 2022. The budget was €3 million, and being also research innovation action, the total budget of the project was financed by the Clean Hydrogen Partnership. The consortium reflects the ambition of the project, gathering together experienced research institutions in the field of solid oxide cells, together with two main manufacturers of the technology. Going through the project, the starting point for ASTRA was to tackle some, let's say, historical and endemic issues relatable with solid oxide cells, like the lack of availability of degradation models, or the lack of availability of some testing procedures able to predict the durability in practical timeframes. To manage and to try to solve some of these problems and tackling issues, the project has been structured, as you see in the center of this slide. The starting point was to choose 3 main components of solid oxide cells to be investigated, which was the fuel electrode, oxygen electrode, and interconnects. And then we asked to the manufacturer to supply real-world samples from stack and cells that operated in a real-world environment for several thousand hours. Then the project has been structured with let's say, a brain that is the orange box that was the data inventory that allowed us to gather and collect together all the information coming from the different work packages that were dealing with several aspects of the accelerated stressing tests. the database collected and structured together all the information coming from the other work packages I was saying. Also, and it was very important also because the information that we exported from experimental point of view, from the modeling point of view, or for post-mortem analysis point of view, was very different from the nature point of view, and was important to collect in a proper way to have always the ability to manage the project and to have a storyline that was important for the project too. The final goal was to basically have deliver accelerated stressing test protocols able to accelerate the degradation phenomenon and degradation rate. Then try to formulate transfer functions able to predict how much you are going to accelerate the degradation phenomena for each test you are carrying on. And the final goal was also to provide information useful for the International Electrochemical Commission in the TC 105, where another group has been created to discuss about the standardization and the possibility for standardization for accelerating stressing test procedures. Going through the results achieved by the project, as I was saying, the main goal was to accelerate the degradation phenomena in a controlled way, and from the experimental point of view, we tried several routes, also considering the 3 different components that we were investigating. The 2 main approaches that we followed was in situ accelerated stress test and ex situ accelerated stress test. The big difference is that the ex situ accelerated stress test was aiming to isolate a single degradation phenomenon and try to quantify the degradation and the acceleration of the degradation that we performed in a control environment, while the in situ aging test was made in a cell environment, always trying to tackle one of the degradation phenomenon that we selected inside the project, but in a let's say in a more real environment and less controlled way. During the life of the project, we carried out several accelerated stressing test procedures. Some of them were also able to become to be structured in protocols. As I was saying, one of the main goals for us was to increase the degradation rate, and we had, in this sense, very good results, let's say, from this point of view. The number that you see on the screen is made with an average about all the accelerating stressing test procedures that we carried out. Keep in mind that each accelerating stressing test was very different from the other, accelerating different degradation phenomenon, and also for the tests that were carrying out the same acceleration, maybe taking them in a different way was the following a different path, leading to different degradation rate acceleration. Of course, the results were that we were able to do an acceleration in a controlled way, and the reflection of this acceleration is the possibility for the manufacturers in the future, hopefully using some of our procedure to manage to have a new concept, new materials, and test it in a shorter way, using less resource in terms of money and time, of course. From the modeling point of view, we follow with more or less the same approach, let's say, from the point of view that we approached the problem on a multiple way, going from local models where degradation phenomena and reactions were investigated singularly on each component at the surface level, inside the bulk level, And then all this data that we collect from the local, let's say, went through a path leading to high-level models and gray box model until the build of stochastic algorithms able to predict the remaining useful life of solid oxide cells and stacks. Going through the exploitation of the project, as I was saying, had the benefit and to have a database that was very well structured and was very helpful for the managing of the project, generally speaking, let's say, but also for the exploitation in particular. Being able to transfer some of our data sets that we collected and gathered inside our database directly in open source platforms like Zenodo, for example. We were also able to publish up to 15 peer-reviewed papers in open access, gold and green. And just last summer, during the last EFCF, we made one dedicated jointly organized workshop together with the Ruby project. Moreover, during the project, we had the benefit to have an external advisory board made of 3 experts from extra EU, already expert in the field of accelerating stressing tests in the solid oxide field from USA, Japan, and Korea. And they were very, say, kind and useful in the exploitation of the project, giving us advice concerning what was doable and what was not. Going through the impact, as I was saying, the impact of the project reflects the ambition that we had and we wanted to tackle in the project itself, with the correlation between accelerated stressing test and lifetime in a user profile, and validate the methodology of how we are going to accelerate each degradation phenomenon. Then the results were gathered together, and as I was saying, an ad hoc group inside the International Electrochemical Committee has been created to discuss the possibility to make a standard of our accelerating stressing test procedures, but of course not only our, but generally speaking. About risk, challenges, and lesson learned. Of course, a project that tackles issues like accelerated stressing tests, that is one of the chimera for solid oxide cells, generally speaking, maybe for the fuel cells, more generally speaking, were a lot. Let's say that we learned some lessons very important for the follow-up in the future of possible new ASTRA projects, like the idea to have a structure, an organized database was very, very useful from several points of view, from the management of the project, but also for the organization of the data itself inside the consortium and outside the consortium. While maybe an advice that we can have, we can go do to our followers, or maybe for ourselves in the future, is that the availability of the history of real world samples provided by the manufacturer is very important, because it's not only important to have samples that operated 20,000 hours, 5,000 hours, but we also need to know an history of what they do and what they did during their life. In terms of start and stop, the fuel utilization, and all the kind of information that is possible to have, it's very important. We supplied to this issue, reconstructing basically and rebuilding the history of the real world samples via electrochemical measurements, and was a huge work very well done and well performed in the consortium, but it was, of course, time consuming. Thank you very much. Should I stop the sharing of my screen?
Yes, thank you very much, Massimiliano. I don't know if there are any questions in the audience. Nope. But then thanks a lot, Massimiliano, and I would like to move on and continue with the panel discussion. So I would like to call the speakers to come to the stage for this last part of the session. And also I would like to call the scientists that we will have during the panel discussion, Beatriz Iborra from the JRC. So please, let's give a warm applause for the speaker again. And I would like to start by introducing Beatriz Iborra Acosta, Iborra from the DG Joint Research Center of the European Commission. And for those who are not familiar with Beatriz, and thanks again for coming, Beatriz. She is an industrial engineer from the Politecnico University of Madrid, has a PhD in nuclear engineering. She is a scientific project officer at the Joint Research Center of the European Commission, and in 2009 she became responsible of the high-pressure gas testing facility GasTEF, conducting research on compressed hydrogen gas storage. At the present, she leads the JRC project's portfolio of sustainable hydrogen value chains and has taken part of the informal working groups of global technical regulations for hydrogen and fuel cell vehicle safety. She is also a member of the ISO TC 107 hydrogen technologies and the CEN-TC 268 working group 5 specific hydrogen technologies applications. I was happy a little bit longer. Thank you, Beatriz. I would like to start by making some questions, general questions, first to Beatriz, and then we can open a little bit the discussion all together. At any time, in any case, feel free to complement or to add anything. Beatriz, well, we have heard we have seen four presentations from projects performing pre-normative research. And as you know, pre-normative research, they are meant to contribute to lay down a suitable regulation content standards for hydrogen, you know. As you also know, this hydrogen strategy, particularly in the first phase, the activation phase, one of the priorities that have been identified is to lay down an enabling and policy regulatory framework. Beyond policies, which is somehow outside of the scope of the JU, no, we feel that where we can make the most contribution is on technical regulations, not in the policy sides. How do you see the role of the JU in general in this context?
Now, you have already explained a part, is the part of the pre-normative research for standards. We have been listening good examples of projects we have produced or are producing nice results and are contributing and are embedded in some standardization activities. But the joint undertaking is not only the projects on the cross-cutting, there are also other projects in the other pillars who has been also largely contributing, and we shall also not forget the other demonstration initiatives that are making good contribution also to establish the framework for permitting, for regulations, and for future deployment of hydrogen technologies in a well-framed legislative environment.
Very good. It's true that from the projects involving big demonstrations, we could also collect, let's say, this experience in the field and try to support as well the RCS development. That's a very good point. Thanks for the suggestion. And also concerning pre-normative research, as the session is pre-normative research, no? We in the JU, we conceive pre-normative research activities they encompass somehow pure research activities, but also desk research activities. Do you think this is the correct approach?
I think it's a very correct approach. I think we have research from labs and from projects, but there is also a very important part to facilitate inclusion of hydrogen technologies in the other part, in the legislative one. And one of the examples, for example, is high-low. Another good example is multi-fuel high, ongoing, where they are studying issues with permitting hydrogen in multi-fuel hydrogen refueling stations. There are many others. Certify is a very good one. Also with the establishing of a frame for hydrogen guarantees of origin, and the results are being taken over and will be taken over in future standardization and in future regulations. So.
Very good. And based on your experience and being in the GRC and having all this background, what would be the priorities in terms of standardization? What would you recommend us to address as a priority?
Wow. Look, many of the priorities are described in the strategic research and innovation agenda of the Clean Hydrogen joint undertaking. There are some things that are appearing now to become important in the short, medium term. According to me, one of them is the large-scale hydrogen storage in whatever mean is coming. This is something which will have to be analyzed and studied and put it probably in future regulations. Liquefied hydrogen, it is in the SRIA. Other liquid hydrogen carriers are also might come important, also from pre-normative to larger use. If we are speaking about hydrogen in the gas system, in the gas pipelines, metering of hydrogen will be is important. It's important to know. Ensuring the quality of hydrogen. We have listened quality of hydrogen for automotive, but quality of hydrogen in other industrial processes, it's something to be taken into account. If we move to mobility and transportation, one of the things we have seen, for instance, in the global technical regulation for hydrogen fuel vehicles will be standardization of crash testing for heavy-duty vehicles and for buses and coaches. And I would not like to forget all the standardization mandate which has come from the alternative fuel infrastructure regulation proposal. And the first part is on the connectors for refueling heavy-duty vehicles, both gaseous and with liquid hydrogen. And I know that there has been calls now on the 2020 work program of the joint undertaking to deal with hydrogen refueling stations liquefied for this. So I can continue elaborating and giving you food for future.
Very good. One very last question from my side, and then we can share the questions with the speakers. We have heard over the weekend that there are some activities concerning standardization in the European Clean Hydrogen Alliance. We also have heard that there are few activities in the sector for our energy management in Sensenelec concerning the needs, identifying the needs for pre-normative research. How do you see the role of the EU and the interaction between all these activities running on standardization?
Okay, now we have to mention that there will be the Regulation Codes and Standards Steering Committee Task Force formed, and kick-off meeting will be soon in November. And I think there is where the joint undertaking can help agglutinating and putting together some of the wishes, for instance, made by the SFEN working groups, the gaps analysis on pre-normative research, the Clean Hydrogen Alliance standardization needs is something which is industry driven and which also the Regulations Council and Standard Task Force can take into account. And not only this, but all other initiatives like the research from Euramet projects we've here. So I think being aware of all the initiatives taking place in Europe, being aware of the European Commission standardization work program and of the annual work program of the SEN is a very important way to also streamline the research that is being done within the joint undertaking projects.
Mm-hmm. Very good, Beatriz. Thanks a lot for the answer. And now let's go through the speakers. And mainly I have two type of questions, so two questions for all of you. And the one is related how, because as you know, we are funding project pre-normative research. We have funded more than 40 projects performing pre-normative research. And one of the main objectives of pre-normative research is to support standards, regulation codes, to effectively support. No? And in that sense, we see different approaches within the projects on how they contact, how they transfer the results of the results, the results of the projects into the standardization developing organization or the relevant technical committees. I would like to ask you, and we can start maybe with you, Arianna. Maybe your case is a little bit difficult because it's not a technical committee as such into the ISO, IC, or Sensenelec, it's IMO, no? But how have you approached, let's say, the regulatory the regulator, let's say, and how it's working, and based on your experience, would you recommend others a different way, the same approach? Can you share a little bit your experience on sharing the results, or expected results sometimes, with these with the regulators?
Yes, thank you. So we start at the beginning to get in contact first with the Europeans and Senelec and then the ISO to present them the project objectives, what we want to aim to, and the initial plan was to get in contact with IMO with, let's say, quite the full package of stuff done. However, we recognize really quite a beginning during the first year project that things are running fast and we cannot arrive at the end of the project with the complete pack to give to the technical committee. So we start to involve members of the technical committee of the IMO that are working on the updating version of the IGF code with hydrogen, involving them in our advisory board. The purpose is both letting them know what we are doing and also having in some way a suggestion also on the methodology, on the first assumption that we have, on the experimentation phase that we have, in some way align step by step the works that are done. Because when we started the project, there was no plan for the IGF code update on hydrogen. 5 months later, they tell to the public that they will arrive at the end of 2024 with the update of the IGF code with hydrogen. That is exactly the same date of the, let's say, final result of our project. So we cannot just wait until then, that part, to exchange data. So we are now establishing a plan to present the first round of the assessment gap during 2023, the assembly that they have, and then we would like to have more than one meeting. It's something that is ongoing, but I suggest to the other project to really start from the day zero of their of their work to get in touch to the technical committee. Because if it's quite easy coming in touch with the European Technical Committee, at the ISO or IMO level, not so easy.
Very good. Jaana, in HYDRAITE, how do you contact, I guess that you were addressing ISO standards mainly. How was it the relationship with the technical committees? How have you approached the technical committees, and any lesson learned that can be shared?
Well, first of all, yes, it was ISO because in our case the standards that we were contributing to, or the development that we were contributing to, is the work is mainly done on the ISO level, and then on the EN level the results are inherited, let's say it so, even though there is also substantial work at the EN level as well, at the SENELEC level. So perhaps we had slight advantage of that some of the partners, or one of the partners had been already involved partially in the work, standardization work prior to this. So we started going to that direction already during the preceding project, HYDRAITE project. So there was a contact point already available. However, I would fully agree with you on that the first thing to do is to contact the TCs and especially the working groups where the work is being made, considering those standards that you are working towards. And my impression is that commonly they are very happy, they are very keen on welcoming you to present the projects that could affect on their work. So that should be quite straightforward first step to take. And when you have made yourself known, then it's even easier to deliver the results and have the communications also with the parties involved in the standardization work.
Very good. I guess that is also applicable for you, Vincent. Have you considered, because there is a way to have a formal link, a formal liaison with relevant technical committees in SENELEC, ISO, and IC level? So can you share your experience on transferring the results into the relevant technical committee? Were they welcome? Were they willing to adopt them? Were there some reluctances? Can you share a little bit your experience and maybe provide some recommendations on your learnings?
Yeah, so in our case actually it was not so difficult or complicated. We requested the PRHYDE members to join the working groups of the ISO and SEN working group, so the ISO working group 24. And so most of the members who joined the PRHYDE working group, they are also in that ISO committee. So it was actually not so complicated to introduce it. Actually, all members of the working group were aware of it, and they were very well informed about the work in progress of the PRHYDE protocol. Yeah. Also, maybe from not only from working group 24, but actually also when I think of working group 28, for example, for ISO 19880-8, what I see is that with working group 27 gives a lot of input to SENELEC for the working group 5 in TC 268 for the EN 17124 standards, but also vice versa, because for the risk analysis is mainly led and driven from the SEN, the EN working group, towards the ISO.
Yes, and
so it goes really in both directions, and I think it's quite good collaboration.
The European standard, they're actually coupled within the same standard. The risk analysis is part of the fuel quality, so that is European work.
Yes,
European
absolutely.
Is leading that part. So well, my mistake going straight forward and stating that it's all inherited from the ISO level. But perhaps my point was also that the importance of formulating these on ISO level is high because it's worldwide task. So not to be done or led fully only inside Europe. That benefits us all.
And to close the round, and not to forget Massimiliano. Massimiliano, I guess that you're still online. And I wonder if you can share your experience. I saw in your presentation and also following up your project that you have succeeded, let's say, and a new working item proposal, at least is on the table for the IEC standard. Can you share with us what was the experience, how long did it take, and would you recommend that this is the best approach to address or to incorporate into the standardization, let's say, sphere, the results of a project supported by the EU taxpayers?
Thank you for the question, Mr. Chairman. Yeah, I would say that the approach that we followed with BA was, let's say, the only one that was possible to follow, let's say, because as I was saying, the pioneeristic approach of the topic and the project needed to create another group inside the TC 105 of IEC. And the procedure that we followed was that the previous coordinator, that was Stephen McPhail, became the convener of this ad hoc group. And of course, this is an extra effort for the coordinator, but is probably the only way to effectively install the communication with the standardization bodies like IEC. So soon, probably the working group will come out with a document about the possibility of the standardization of accelerating protocols, and they will have the final draft probably in a few months. But the only way, in my opinion, to gather and to collect together a project like ad ASTRA, and dealing with something that is a very low TRL, and an international body for the standardization, is to create another group where the convener is the same, at least is very involved in the project.
Very good, Massimiliano. Thank you very much. A very last question from my side. We are running out of time because, as you know, we are supporting financially the research. We are glad to support you financially, but when transferring the results into the standardization development organization or the regulatory organism, do you think that the JU could help you in something else? Could we provide any support that you were missing when you were facing these transfer of results? Would you have, Vincent, do you have an opinion?
Yes, I have an opinion. Actually, I already discussed with Mark earlier. Maybe not all authorities and so on are aware of all the standards that need to be used or that are recommended. Even not all the notified bodies are aware of it. So maybe to create a little bit more awareness of some specific standards that need to be followed towards the authorities.
Very good recommendation. Thank you. Jaana, based on your experience, any recommendation, any I don't know, certainly were you missing sort of an endorsement when addressing the technical committees, or do you feel that can we do something else?
Well, we also had a quite good starting point, as I mentioned, that one partner was already involved, and later in later phase of the project, many of the partners were directly involved in the standardization work and the technical committees, working groups. But perhaps in addition to making awareness of these standards that are there and that are available, but making awareness of the standards that are not there, the kind of the starting point of the discussion today, that has a high importance to really to be able to establish those in
continuously I hear authorities or companies saying, oh, we have 5.0, so it's okay. Hydrogen quality 5.0. So they are not aware even that there is even a specific standard for hydrogen quality.
Okay, good point. And what about IMO, Arianna?
I think that maybe also for the other discussion that they say, we are quite single entity as a project contacting a single technical committee, so it's so fragmented. We also were lucky because the person in charge of the project in Uni is the same that is working in a technical committee in ISO and in Sense and Elect, so this is quite a lucky starting point, but I think that clean hydrogen could not rely on lucky starting point on having people that working.
No.
So I think that it's important for the visibility that the clean hydrogen could present the complete effort that they are doing in, let's say, providing pre-normative research for standards. That could leverage a bit also the awareness for IMO, for us certification and class society, flag, and all the others, let's say, companies or certification body or authority, policymaker that needs to use standard every day. So I think that if clean hydrogen could present themselves with a complete overview on the effort that they are doing, it could also help projects to present themselves as a part of a bigger family.
Very good. And last but not least, Massimiliano, any addition? Do you agree with what we have heard? Did you miss anything when facing IEC and the relevant technical committees, despite the former coordinator was the convener of the relevant working group?
Yeah, let me say that I really agree with the last sentence of my colleague. In our case, like our case, for example, where we are tackling something niche, a specific topic, like, for example, accelerating stressing protocols, the connection with the similar topics and oh, sorry, can you hear me?
Yeah.
No,
okay, sorry.
Sorry.
So because I can see only you, Alberto, that's why.
I was just saying that after this we were finished. Sorry.
No, it's okay. No, I was just finishing. I mean, in our case, the difficult was quite obvious. Nobody did it before, and nobody knows even what an accelerated stress test is and how can be defined in a standardized way. So to collect the similar experience from other EU project and put together the expertise also at the IEC level, it would be a lot.
Very good. And last but not least, sorry, Beatriz, do you have any addition? Yes.
Yes,
Like
and it's from the other way around. We have very nice projects, getting very nice results. We know that the standardization times are somehow different than the timing of the projects, but we have to ensure continuity of the projects, and we have to ensure that they become part and continue being part of the standardization project. And one thing that the joint undertaking can do is to preserve the knowledge, to have a repository on the project results, place where also standardization working groups can go to set results and maybe exploiting the joint undertaking knowledge hub, and also making sure that when relevant there is reference, there are bibliographic reference to European research-made projects in the standards. I think this is also a very good way of supporting projects and future projects.
Very good. Thanks a lot for this last comment. And with this, I'm afraid we have come to the end of the meeting and the parallel session. So I would like to thank again to all the coordinators and the speakers on behalf of the project. Thanks again to Beatriz for coming from PET in the Netherlands and sharing her views on this particular topic. And yes, we will close the meeting. I would like just to remind everybody that for those who are in person here, we have a networking drink on the second floor. So I hope you can join us. It's on the second floor, networking drink in a few minutes. So thank you again, and see you soon. Bye-bye.
Okay, you could find my contact via the